Okay, so today we're looking at properties of circles, part 2. So what we're going to be doing today is just a quick recap. So we need to remember that this here is called the central angle. When the angle starts at the center and goes to any two other points on the circle. So you know whatever's here is going to be the same as the arc up top. So if we know that this angle measures 34 degrees, that this arc will also measure 34 degrees. And like we said, this right here is called the central angle. And now the other type of angle that we have is called an inscribed angle. And this is when there's a center of the circle, but we have another point on the end, and this branches off to two other points on that circle without touching the center. So we know that if this angle right here measures 25 degrees, we know that this arc up here is going to have to be double that 25. So 25 times 2 is going to give you 50 degrees. So whenever we have an angle down here, we know in an inscribed angle, the arc is always going to be that angle multiplied by 2, and vice versa. The arc in an inscribed angle will always be, the angle down here will always be 1/2 of the arc. So now let's go ahead and look at another example of this problem. So we have our circle with center C. And we have our diameter with segment ED. We have point A right here. We know that this measures 45 degrees. This is point F, and this is 60 degrees. So we have to find a few things. So right now we're asked, okay, so before we find anything, we're given that segment ED is the diameter. We need to find 1, the measure of angle FCD, 2, the measure of arc AD, 3, the measure of angle ACD, and 4, the measure of arc ADF. Let me redraw that. Measure of ADF. That arc. Yep. Okay. So now let's start with number 1. So we know that arc FD is equal to 60 degrees, right? And we know that angle FCD is a central angle, right? Because it starts at the center and goes off to the radius D and the radius F. So we know that whatever is here is going to be the exact same thing here. So we know that the measure of angle FCD is going to be 60 degrees because this is a central angle. Now we need to find the measure of arc AD. And the way that we can do that is we're given that segment ED is the diameter, right? So we know that what a diameter does is it splits the circle in 2. And if a circle itself measures 360 degrees, a semicircle, or a half, semicircle is equal to 180 degrees. But we already know one of those angle measures, and that's 45 degrees. So all we have to do is 180 degrees minus 45 degrees is going to give you 135 degrees. And you know that this is the measure of arc AD. Now we need to find the measure of angle ACD. So ACD is right here, right? It's this angle. But wait, we just found the measure of arc AD. And since this angle ACD is a central angle, it has to be the same thing as this arc, right? Because it's a central angle. So all we need to do is just draw that arrow. It's going to be the exact same thing. So this is also going to be 135 degrees. Now we need to find the measure of arc ADF. So this whole thing, right? Now, the best way, the way that we can do this now is taking what we just found of arc AD. This is equal to arc AD plus arc DF. And we already know both of those. So all we have to do is 135 degrees plus 60 degrees. And that's going to equal 195 degrees. So now we just solve for all 4 parts that it was asking for. So let's go ahead and look at another problem. So now we have another circle with our center, and we have our point right here, our vertex. We have one chord here and one chord here. This is LMN. We know that this angle measures 26x, and we know that arc LN measures 51x plus 3. So in order to solve this problem, we need to recognize that angle LMN is an inscribed angle. So that means that whatever is down here, so the 26x, we need to multiply it by 2, and that's going to give us whatever 51x plus 3 is. So we can do that first. So 26x times 2 is going to equal 51x plus 3. It's going to give us the same answer, right? So now we just need to multiply this out. 52x is equal to 51x plus 3. Subtract 51x from both sides, and you're going to get that x is equal to 3. So now we can actually check this, right? So if we substitute x or 3 back into x, we can do 26 times 3 is going to give you 78, okay? Now 51 times 3 plus 3 is going to give you 153 plus 3, and that's going to give you 156, right? Is equal to 156. Now we need to check that this top one is double this bottom one, right? So 78 times 2 is equal to 156. So we're good on both of those. So let's look at another example here. So again, we have our circle. We have a diameter here of BAC. We have a point here, D, and we have a chord here, and another one here. But this gives us a triangle, right? So we're given that this is 23 degrees, and we want to find this 3x minus 2. So what we need to know here is that we have that segment BAC is the diameter. And what that means is that when we have two chords here, we know that segment BD is perpendicular to segment DC. Just because whenever we have the diameter and we have two chords come from the endpoint and meet on that same semicircle, so at point D, we know that this is going to give us a right angle. And what we can do now is that we know that this angle here has to be 90 minus 23, right? Because we're given this 90. So 90 minus 23 is going to be, that's going to give you 67 degrees. So you know that this is 67 degrees. But we know that angle DBC is inscribed. So we know that 67 is half of what 3x minus 2 is. So what we can do is 67 times 2 is going to be equal to 3x minus 2. We can set that equal there. Now we know that 134 is equal to 3x minus 2. 136 is equal to 3x. X is equal to 45.333. So now what we can do is check this out, right? Double check our work. So substitute back in 45.333 to 3x minus 2. And you're going to get 3 times 45.333. And that's when we round it, because we're rounding to 3 decimal places, that's going to give you 135.999 repeating. But you're going to round that one up, and that's going to give you 136. Subtract 2, and it's going to give you 134. And 134 divided by 2 is going to give you our 67 of what we started with up top. So so X at 45.333 is the correct answer. Now this last example is a little quicker. So we have our circle, right? Again, nothing is touching the center. We have one point here, touches up here and here. And we have another point here that touches, not the center, but this point here, and also touches this point here. So it's given that this angle measures 3x plus 7, and this angle right here measures 6x minus 11. So what we can do is just set these equal, because we know that they're both inscribed and both of their endpoints are the same points. We can just call this A and B, right? They both touch A and B. So we know that these are going to be the same thing, and since they're both inscribed, we don't have to multiply by 2 or divide by 2. We just need to set them equal. Is equal to 6x minus 11. Subtract 3x, you're going to get that 7 is equal to 3x minus 11. Add the 11. 18 is equal to 3x. X is equal to 6. And again, you can check that this works for both of them. 3 of 6 plus 7 is going to give you 18 plus 7, which is equal to 25. And then you can check it with the other one. 6 times 6 minus 11 is equal to 36 minus 11, which is equal to 25. Perfect. So you know that they're the same, and that x being 6 is correct.